Good evening, everybody. Tonight we're going to be talking about combining like terms. So yesterday or the last lesson we did was just distributive property. We learned how to multiply through and deal with the variables, but oftentimes what that leaves us with is a really long set of variables, coefficients, constants, and we need to be able to combine those together before we can actually begin to solve the problem. So our lesson tonight is going to be just looking at how do I figure out what is allowed to be combined and what can't I combine. So I'd like you to just really pay attention to the lesson, take good notes as we begin this again, following the WINS profile, and let's get started. So as we look at this combining like terms, let's think about it this way. The first example up here is 4 apples plus 5 apples. Well, if I told you that Bill had 4 apples and John had 5 apples, and we asked how many total apples they have, I don't think there's anybody who would deny that there are 9 apples. We'll make it an A, okay? But if somebody said there are 4 apples and 5, I hate this word, bananas, then I don't think there's anybody out there who would say there is 9 apple bananas, okay? So I want you to think about that in the context of combining like terms. Do we have a similar term? And if it is similar, can we combine it? Another way of looking at that is we have a 1. We can add a 1. We have a 2-dimensional figure. I have 2 squares, and I want to add a 3rd square. How many squares do I have? Well, I have 3 squares. Again, I don't think there's anybody here who would say that 1 plus a square equals 3, whatever we would call that. One last example. We have a cube. We have a second cube. If I was to add a 2-dimensional figure, can I add those together? Well, this is a cube, this is a cube, so how many cubes do I have? I have 2 cubes. Can I add this 2-dimensional figure? No. So let's start with some easy examples and we'll move on. So, combine 4x and 5x. I have 4x's, I have 5x's. So when I add them together, I end up with 9x's. I have 4y and a 5x. Will they combine? No. 4y plus 5y. Well, how many y's do I have? This says I have 4y's, this says I have 5y's, so I have 9y's. Very straightforward. All right, now life starts to get a little complicated, and I want you to start learning a little technique to keep things even. We look here and we say, okay, we've got some A's and we've got some B's. Got some A's and we've got some B's. Well, I want to keep track of all that. So, I have an A, I have an A. This looks like 3A minus 7A. So 3 minus 7 is negative, and that is an A. This is 4B plus 5B, so that gives me plus 9B. You see how I underline it? Some people like to put a cross through. The problem I have with that is now you can't see what your original number was. So when you do that, you can't really see what your numbers that you were working with. I like to personally underline each of the items so that when I am done, everything should be underlined. If it's not underlined, I haven't taken care of it. So my answer here would be negative 4a plus 9b. 2 plus 7x. This is a constant. This is a coefficient with a variable. Can I add 2 plus x? They are not the same, so my answer is 2 plus 7x. 2x plus 7x gives me 9x. Let's go back here. 2x, 7, 5x, and negative 4. So I see again that I've got some things that are the same. I'm going to underline the 2x. Going to underline the 5x. That's going to give me 7x. Going to underline the 7 minus 4. That's going to give me 3. Okay, let's take a look at some more complicated ones. 2x cubed plus 3x squared minus 2 plus 3x squared. Well, let's go from left to right. 2x cubed, 3x squared minus 2. Which has the largest exponent? Well, this one right here, right? A 3. So, underline the 2x cubed. Do I see any other terms which are cubed? No. So I rewrite it. 3x squared, looks like the next biggest one. There's a 3x squared. Are there any other x squareds here? Well, it looks like there's another x squared there. So 3x squared plus 3x squared. How many x squareds do I have? Well, I had 3, and I had 3 more, so now I have 6 x squared. This is just telling me how many of this quantity I have. The only thing I have left now is negative 2. Okay. Let's do one last complicated one, and then we'll call it finished for the evening, because combining like terms is very straightforward. So we're going to do 3y squared plus 6x squared minus 3y plus 2x squared minus 2y squared plus y. Well, you can see that's quite a mess. But let's just go through. We can either start with the greatest exponent, like I said, or we can just start with the very first quantity. 3y squared. Now I'm looking for just y squared. 3y squared. No. 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 Yes, that's a y squared. 3y squared minus 2y squared. 3y squared minus 2y squared. I have a y squared left. I have a 6x squared. Is this an x squared? Nope. X squared? Yes. 6x squared plus 2x squared is 8x squared. Come to here. Minus 3y.
Ms. Metcalf, if you're still in the building, please call extension 2303.
Plus y minus 2y. And I'm finished. This is covered, 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 covered. I've combined and simplified my like terms. Okay, well, that's going to end the lesson. I hope that's very straightforward to you. We'll practice a lot more with some more complicated ones. This is very important for you to get underway, making sure that you focus on the positives and the negatives, so you're adding and subtracting in the right spot. Your quiz tonight will be on quiz number 15. Good night, all.